Hello.
Hey Nico, it's Matthew. I
Hi.
think Jamie just joined also. I'll ask him to unmute here. Hey Jamie,
Hello.
what would you guys like to work on tonight?
I have some web assignment that I'm kind of confused about.
Sure. Sure. Jamie, you got some things you'd like us to look at?
I don't have any problems specifically. I was just wondering if we could go over like the verifying things.
Sure. You may want to, Jamie, come up with either show me some that, were more challenging than others, or
I'll look some up right now.
do you guys have a rodeo break this week?
Yes.
All right. Good thing they don't make you go to the rodeo to get the days off.
Oh yeah.
might not work out that well.
I know. I think I sent you over some stuff.
Yeah, I see Nico sent over an image, some web sign here.
I just grabbed my book and I'll send some over.
Are you guys, did you guys forward a invite to Aiden? Do you know that person?
No.
No.
Okay. Well, you're not expecting anyone else to join, is that right?
Yeah, no one to join.
Okay. Right. Yeah, so let me look here. So 2, 3, 4, factor the expression, use the identities. Oh, okay. Yeah. All right. I see what it's trying to get you to do here. All right, I'll share my screen here shortly. And we'll get started here. Thanks again for scheduling. All right, here we go. So if you're seeing my screen, factor the expression here. So Niko, you sent this over. So the one in the numerator is difference of squares, a squared minus b squared. So that's a minus b, a plus b. And in your case, it's cosecant squared x minus 1 squared. So your numerator is going to become, I'll write it down here, 2 cosecant x minus 1 cosecant x plus 1. And then on the bottom, you still have this 9, but you have this cosecant x minus 1. It looks like these cancel. So your final answer is just 2/9 cosecant x plus 1.
Okay.
Okay, let's look at another one here. Look at number 3. Okay, snipping this in. So this one says perform the indicated operation and simplify. Okay, so this looks like FOIL. Maybe we get something out of it. Not sure yet. We'll take a look here. So we get 5 halves times 1/7 tangent squared x minus, let's see, the outer and the inner are going to be the same. Hopefully you see it like you're going to have a 5 halves times a 1/7 and a 5 halves times a 1/7. So those are just going to cancel. So I guess this is sort of undoing. It's a minus b, a plus b becomes a squared minus b squared. And so it becomes minus 5/2 times 1/7 secant squared x. So from here, we might be able to use an identity. I'm not sure at the moment here. So this becomes 5/14, and you can factor it out. That's tangent squared x minus secant squared x. And then do you guys have those identities up
Yeah.
from before? Is it, I think it's, what is it? Tangent squared x plus 1 equals secant squared x.
Yeah.
Yes.
So let's see, your tangent squared would equal secant squared minus 1. So this is secant squared x minus 1 minus secant squared x. And why does that help here? Well, actually, I'm sorry. So yeah, that's fine. So the reason that helps is the secants cancel. You still have this 5/14 on the outside. Then you got a negative 5/14 there. Jamie, did you send over something you'd like us to look at? Looks like you did.
Yeah.
You sent, I guess I'm not sure here. You sent like which of these problems here?
Oh, can we go over the one with the image?
The friction. Sure.
Yeah.
Okay. Just to be clear, that this problem is they're not asking you to actually set up the equation. Like they already set it up for you. Like this is given.
Yep.
Right. So is it okay if I just solve this, or do you want me to go through the physics of why this becomes this equation? Is that of interest?
I guess just like how to solve it.
Okay. So we're just solving it from you. You're going to divide both sides by W cosine theta.
Mhm.
So the W's cancel, that cancel, W's cancel, and mu equals tangent theta.
Oh, I didn't see that.
And if you guys ever do a physics lab, this is like a classic physics lab that you would see. They you know, this ends up being the equation for friction.
Got it.
All right, Niko, let me jump back to your question number 4 here. These don't feel like they're difficult enough to be exam questions, but you know, there's only so many things they can test here. Also, I mean, you got a limited number of identities and things like that. So first thing I see here, Niko, is that the 8/5 factors out of both. So you have secant to the 4th x minus tangent to the 4th x. And then inside here, like I see difference of squares. I see an a squared squared minus a b squared squared. And when we get it down into squares, then we can use some identities. So this is like secant squared x minus tangent squared x times secant squared x plus tangent squared x. And I'm just using this same as above there that we used. So this one we worked earlier, tangent squared x plus 1 equals secant squared x. Notice it doesn't matter whether I substitute in for secant squared or tangent squared, I get the same answer. So this time I'll substitute it in for secant squared. So this becomes tangent squared x plus 1 minus tangent squared x. You got that 8/5 out in front, and then this comes down the secant squared x plus tangent squared x. So inside parentheses here, the tangents cancel, leaves you with 1. So you get 1 times 8/5. 8/5 secant squared x plus tangent squared x, which isn't anything. This does not reduce. Jamie, maybe you already did question 4. You could probably verify that your answer has this in it. If you got your web sign up still, you don't have to.
Yeah, it has both of them in it.
Yeah.
Okay, I think my issue is that I made like secant squared x plus tangent squared x to 1. So yeah.
Yes,
okay.
we would love that to be the case, but it is
Yeah.
not. It is not. It's not an identity.
I think I was just hoping for it to be like that.
Yeah. All right. Jamie, anything else on that page that you sent me that you want us to look at?
I'm sending 2 more right now.
Okay. Have you guys gotten into like sum to product, product to sum, half angle, anything like that yet?
I don't think so.
No.
Okay. Yeah, I mean, here's a great list of questions. Any of these kind of jump out at you?
Can we start with 50?
You just want to go right to the real the real hardcore one. Okay, sure.
Yeah.
Yeah, these are great. All right. Which side is more complicated in your opinion, Jamie?
Definitely the left.
Yeah, I agree. The thing that jumps out to me first is that the top is sum of cubes,
Mhm.
and there's sum of cubes and there's difference of cubes, and the
Okay.
formulas are very similar. And it's the kind of thing, like every time it comes up, it's like, well, do I need to remember it? It's like, well, maybe for one problem on one exam. I mean, I wouldn't, set your schedule to it, but you want to either know how to find it or quickly remember it for an exam. And they're really similar. So hopefully by seeing them, you guys can pattern.
Shoot.
You see, you really only have to remember one of them and then remember the difference between them.
Mhm.
Okay, so if you've got that down, sorry for jumping around so much. The numerator becomes sine beta plus cosine beta. And I'm doing this top film here, and then it's sine squared beta minus sine beta cosine beta plus cosine squared beta all over sine beta plus cosine beta. So obviously these cancel, okay? And then Niko, this is the one you want. This is the sine squared plus cosine squared. That becomes 1. Now remember, I'm probably not doing this exactly the way your instructor wants it. They may want you to write out that sine squared beta plus cosine squared beta equals 1 off to the side. I'm not writing it. I'm just showing the end result of it.
Mhm.
So please, do what they do what they want. Can I go back and do 48? Would that be worthwhile for you guys to see?
Yeah.
Okay. Niko, while I'm working on this for you guys, maybe send over a couple more WebAssign.
Okay,
Maybe
yeah.
it'll spawn some other conversation. So, Jamie, which side is more complicated in your opinion?
Probably the left, I want to say.
So I would agree. The reason is because there's a sum or difference in the denominator. You could actually work on either side here. Now, whenever you have, sorry for that, whenever you have a -1 or a +1, you generally multiply by the conjugate. That's just like you have to remember that because it's just not obvious.
Mhm.
I mean, you guys probably are driving now and, you learn to parallel park and you probably haven't had to parallel park very often, but it's like when you do, you need to know how to do it. And this is that case. And the other thing is that this cosecant alpha +1 is up here on the right. So we're kind of like feeling like, oh, that's pretty good. We must be on the right track.
Mhm.
Okay. So in the denominator becomes cosecant alpha squared -1. It's an A minus B, A plus B situation. The numerator, you do not multiply, mostly because you see that it's kind of what you want up here. Okay. Okay, so there's the 3 identities, right? There's sine squared plus cosine squared equals 1, 1 plus tangent squared equals secant squared, 1 plus cotangent squared equals cosecant squared. These also kind of pattern, if you notice that as well, to remember them. So the cosecant squared minus 1, this one on the bottom is cotangent squared. So, you have
Oh,
so whenever
got
you
it.
see a squared, you have to be looking out for these identities. That's just the name of it's just the way it goes in this game. So you have cotangent squared alpha, from these, and you can see that that one cancels with that one, leaving you 1 on the bottom, which is exactly what you wanted in the first place.
I see.
All right, Niko, you sent over another wonderful
couple.
trig substitution. Okay. Yeah. I think I mentioned this to you guys last time that Calculus 2 students get these problems, and they really struggle because they're just weak with their trigonometry. So if you plan to take more math, that's the reason you're going to see this again, and it's too hard to learn it, in that time frame. So what they're trying to show you here is that, let me do it this way. They're like simplify this, and we're going to tell you that 5x equals 6 tangent theta. And you're supposed to go over here and be like, well, I don't have a 5x, I got a 25x squared. Well, you get that from squaring both sides. So you get 25x squared equals 36 tangent squared theta. So instead of 25x squared, you're going to replace it with 36 tangent squared theta. And then this plus 36, that just comes with it. So now you factor out a 36, and you get tangent squared theta plus 1. Off to the side here, remember that square root of a times b is the same as square root of a times the square root of b, which means that this becomes the square root of 36 times the square root of tangent squared theta plus 1. Square root of 36 is 6. Tangent squared theta plus 1 is an identity. Remember that 1 plus tangent squared theta equals secant squared theta. So it becomes the square root of secant squared theta, and the square root undoes the square, so it becomes 6 secant theta. There's a few variations on that same problem that you guys might see. So and they're really emphasizing these trig identities. Now, that may not be your answer. Does it say to write the answer in terms of theta?
Yeah.
Okay, so in calculus, you would have to write it back as with the x's, but it does say to write your answer in terms of theta.
Yeah. Function theta. Yeah.
Yeah. Okay, Jamie, sent over some questions here. Let's see. Use the co-function identities. Okay. Why can't I rotate this? Okay. All right, let's look at like 62. Like the one way this exam could work for you guys, or quiz that you might have upcoming, is like they give you one problem of each type. So they make you remember every single one of these things. I don't have a really like a good, I can't like say like, oh yeah, like learn this, learn that. I'm not sure. So like you shouldn't immediately be drawn to these two, 18 and 72, because they add up to 90. And same with these in here. Okay, now why is that helpful? Well, sine squared 18 is the same as cosine squared 90 minus 18. And that becomes cosine squared of 72. And then if you bring this sine squared with it, these two equal 1.
Oh.
Now you could have also, let me just, and you'll see the other one's exactly the same. You could have also done the following. Because Matthew, I don't like that. I like this one here. I'm gonna go cosine squared 90 minus 72. Well, that's also cosine squared 18. That goes with this one as is, sine squared 18 plus that, because the angle is the same. So when you see sine squared x plus cosine squared x equals 1, the angle can be anything as long as it's the same.
Mm,
And they don't
okay.
even, and again, they don't even have to give you one. They could just tell you it's X, or they could tell you it's, 10 billion. It's always 1. Okay, so this other one is the same thing. You just convert one or the other, but not both.
Got it.
Okay, if you convert both, you just go, you get back to where you started. So, this one on the left is cosine squared 90 minus 40. That's really cosine squared 50 plus sine squared 50. That equals 1 also. So it's 1 plus 1, final answer of 2. And again, they could do it with the other identities also, which is how I would do it. Like if I were testing this with the identities. So what I mean by that is we know that like 1 plus tangent squared theta equals secant squared theta. So I would give you something like tangent squared 314 degrees minus secant squared 314 degrees. And hopefully you guys would somehow would get you to recognize that this equals -1. Because we subtract this over and you get to move this over. Is that okay?
Yeah. I think that makes sense.
So keep that. Again, these identities are just so important. They just come back over and over and over again in this class. Niko, you also sent over, sorry, I guess
one more.
I couldn't read it. Sorry, you're gonna have to
Yeah,
resend it. It's
I'll resend it right now.
yeah.
It's a long problem.
Yeah. If you can narrow your screen and snip it would also be helpful.
Yeah, I'll try that.
Jamie, any WebAssign you need help with or anything else kind of coming to mind?
I'm good on WebAssign because I finished that one, but I do have a quick question actually.
Sure.
Which ones, like for example, sine of -x, which ones become like negative sign and which ones like stay the same?
Okay, so sine is an odd function.
Mhm.
So that's why this is true. Because sine is odd. So which ones are also like sine? Well, cosecant becomes negative cosecant x. Because cosecant is really sine.
Mhm.
Okay. Now, how about tangent? So tangent's a little bit tougher. So let's break apart tangent of minus x. Tangent of minus x is really sine of minus x over cosine of minus x. And sine of minus x, we just said, is minus sine of x. Okay, which makes it, and then I'm sorry, cosine is even, so it just takes the negative away. So this becomes negative tangent of x. So notice that tangent is also odd. You would also get that from its graph. I guess it looks like that. I don't know. I have to look. Cotangent is also similarly, cotangent of minus x is equal to minus cotangent of x for the same reason. So the only ones that are even, if we're making a list here, the even ones are cosine and secant. And the odd ones are the other ones, sine, cosecant, tangent, and cotangent.
Okay.
And that, does help you on occasion when you're trying to like,
Yeah.
use one of these formulas that feels impossible to do. Okay. Since you already did this one, Jamie, would you be willing, you can say no, to give us your explanation of how you might do this, and take a minute or two just to, revisit what you did with this, but we have plenty of time here. So, if you're willing.
Okay. I probably could explain it.
Okay.
So the first thing I did was I pulled up Desmos
Okay.
and just plugged in the equation.
You just graphed it. Why did you do that? Why, like, what made you say, oh yeah, let's figure out what this thing looks like?
Just because I wanted to see like when it was like less than or equal to 10, as well as greater than or equal to 0.
Okay. So we got time here. I might as well do that. Let me get that up on my other screen. All right, if you're seeing my screen, I'm sharing that graphing calculator.
Oh, yep.
All right. Oh, I used the wrong variable. So you generally use X, not T. Okay, so you got a graph that looks like this, hopefully.
Yep.
All right, so and they just want it from 0 to 10. So actually that's our other one. 0 less than X less than or equal to 10. Okay, so we see this thing, it's bouncing. Okay. Okay, and then do you remember what you did next?
So then after that, what number is it not supposed to equal to, or like not supposed to exceed?
0.85 is what it looks like. It says does not exceed 0.85.
Okay, and then I just went to one of the points. Let me see which one it was. It should be, I think it's that 1.434, I want to say is what I went to.
Is it the last point that you used?
Yeah.
Yeah, so that's this one, I guess, right here.
Oh, shoot. Okay.
So
Yeah.
Niko, maybe give that a try. See if that point works for you.
Okay.
And what was weird for mine, mine actually, according to my teacher, was glitched out. Like this is one I asked her about because mine was not working.
Okay.
And she looked at what I did, and I had gotten what I was supposed to get. Like she went over my work.
Okay.
It wasn't what the WebAssign wanted.
For this one?
Like mine was really weird.
Okay.
I don't know if Niko's will be the same.
Yeah.
Mine worked.
Great.
Okay, then perfect.
Let me snip this into that other screen, and then I'll go back and share in case you guys want to look later at it. Okay, what else would you guys like to look at today?
Let me check my textbook.
I'll send a couple more things over.
Okay, that would be great.
Yeah, let me just take a look at the textbook and see.
Okay, I just sent one over. Can we do 33 and 34 in it?
Sure. All right, so does 33 say sine squared x equals 3 cosine squared x?
Yeah,
And are these to be done by hand or with a calculator or?
by hand.
Okay.
And oh, they're solved, by the way. They're like a solved one.
Yeah, 3 cosine squared x. Okay. So first thing is when you're solving equations, you generally get everything onto one side, especially when they're squareds. Because they're squareds, you're going to use one of the Pythagorean identities. So what I'm trying to, so let me move, I don't know. Did you have a preference here for moving like cosines left or the sines right? Do you have a preference here?
I have no preference.
Okay, so I'm going to move it left. Sine squared x minus 3 cosine squared x equals 0. And then sine squared x, or one or the other we have to convert. So it's either cosine squared x is 1 minus sine squared x. For some reason, like that is my preference, but you could also substitute for sine squared x. It doesn't really matter, but I'm gonna substitute in for cosine squared. So it's 3 times 1 minus sine squared x equals 0. And then you just distribute in minus 3 plus 3 sine squared x equals 0. So you got 1 sine squared x, 3 sine squared x's, that's 4 sine squared x minus 3 equals 0. And you solve for sine squared x. You sine squared x equals 3/4. And then you take a square root of both sides. So the square root of both sides is plus or minus. So you get sine x equals plus or minus the square root of 3 over the square root of 4, which is the plus or minus the square root of 3 over 2.
Gotcha. Okay.
Now we're not done, but you got to know this part's kind of the easy part. You got to just go to your unit circle and figure out where these are. So there's going to be 2 answers per, one positive, one negative. So if you don't have a unit circle handy, we're looking for where sine x is positive square root of 3 over 2. So that's like here and here. So pi over 3 comma 2 pi over 3. And then negative square root of 3 over 2, that's here and here. And these actually end up just being multiples of each other. 4 pi over 3, 5 pi over 3. Is that okay, Jamie?
Yep.
Niko,
worries.
any questions on that?
I got it, I think. Yeah.
Okay. So 34 isn't really that much different. Let me see what Niko sent over first before.
Mine's also 34 on that one. It's like the square root problem.
Yeah, that's awful. Okay, we'll get back to that. Get back to that. So Jamie, the just, is it 3 tangent squared x minus 1 tangent squared x minus 3?
Yep.
Okay. Grab that. So we got 3 tangent squared x minus 1 parentheses tangent squared x minus 3 equals 0. If these weren't trig functions, like if it was just 3x squared minus 1 and x squared minus 3, you would know to just set them equal to 0 and solve. And that's the same thing that you do here.
Oh, okay.
So it's 3 tangent squared x minus 1 equals 0, tangent squared x minus 3 equals 0. And you just solve these individually. So it's tangent squared x equals 1/3. Tangent x equals the square root of 1/3 plus or minus. And then on the right here, it's tangent squared x equals 3. So tangent of x equals plus or minus the square root of 3. Okay, so on the left here, it becomes plus or minus 1 over the square root of 3, but then you rationalize it. So you get tangent x equals plus or minus the square root of 3 over 3. So again, you just go to your unit circle to figure these out. And I mean, these aren't great, but I mean, they're good for learning your unit circle. So like here it's 1/2 square root of 3 over 2. No, square root of 3 over 2 comma 1/2. So the tangent of that, and this is pi over 6. The tangent of that is 1/2 over the square root of 3 over 2, which becomes 1 over the square root of 3, which is this first one, which becomes this. So basically every angle except the 45s is going to give you one of the answers. Like you don't have to work that hard here because you just know like, oh, well, the next one works out too because it's the other one. And if that's not clear, like you just want to work out, well, what is square root of 3 over 2 over 1/2? Well, it's square root of 3, which is this one. But if it's 1/2 over square root of 3 over 2, it becomes the other one. So it's just each of these non-45s in your unit circles.
Oh, all right.
So that kind of shortcuts it a little bit. So it's So the final answer is pi over 6, pi over 3. But I wouldn't do it that way. I would do it as multiples. I'd be like, okay, it's 2 pi over 3, 4 pi over 3, 5 pi over 3. And then the pi over 6s I would do, okay, 5 pi over 6, 7 pi over 6, 11 pi over 6. Yes.
Gotcha. Okay.
Believe me, you guys can do this. I'm not looking at unit circle or anything. You guys can absolutely do this. Just need a little more practice. Seeing it a few times. Okay, Niko, you said 34.
Yeah, the really like the square root problem.
Okay. Yeah, it's horrible. This one is a half angle, I think. I need to check. But let me get back to that. All right, so let me snip this in. Okay. The left side to me appears more complicated than the right.
Yes.
Okay. And this is kind of interesting. We'll talk about that. So I mentioned before that the approach for solving these is often the conjugate. So you're probably distracted by the square root. The square root's gonna be there most of the time. It's 1 minus cosine theta, 1 plus cosine theta, but you're gonna multiply the top and bottom by the conjugate. 1 minus cosine theta, 1 minus cosine theta. So on the bottom, that becomes, you get your a plus b, a minus b. On the bottom, it becomes 1 minus cosine squared theta. On the top, it's 1 minus cosine theta squared because you get 1 and 1. Okay. On the bottom here, 1 minus cosine squared theta, that's an identity. So you should be like, oh, that's sine squared theta. You should be always on the lookout for those. Okay, now you can take the square root of the top and the square root of the bottom. So the square root of the top, 1 minus cosine theta squared. You can see the square root undoes the square. Now on the bottom, this is kind of interesting. You guys may not remember this, but the square root of x squared is actually the absolute value of x. So remember I did this problem earlier. Sorry, now maybe I'm scrolling so fast, but let me go back to it. Where is it? Right here. See how this was the square root of secant squared? This is actually not correct. It's actually 6 absolute value secant theta. But a lot of these problems like assume you can only do positives, so they don't like start putting that in there. But if you want to be that like gold star triple A+ student, like you'll remember this every time. But it does matter in this problem because the bottom is absolute value sine theta. And the numerator is just 1 minus cosine theta.
Hmm.
Okay. Okay.
Jamie, anything on that you would like clarity on?
That makes sense.
You seem like you're like, well, like, if like, okay, great, I saw it, Matthew, but like, do you think you could do it on your own? Like, what would be your stumbling block to be able to get this done on your own?
I'd probably just have to remember the square root of x equals the absolute value of x.
Yeah. Yeah,
That's
I mean,
probably the major thing.
yeah. A lot of distractions, you know, like this square root is very distracting. Like, how can that become that? But if you sometimes you attack a problem, you say, well, what if it wasn't there? What would I do? Well, you multiply with a conjugate.
Mhm.
Right. So that takes care of that. Niko, any others from this wonderful page you've sent me?
Let me just make sure. I think that's all from that page. It was just that one was just horrifying to like look at. So
Yeah. It's
yeah.
not great. I'm sure whenever like someone came up with this originally, they were pretty excited, but we don't really understand the value of this. You know, like what's the application of this? And I couldn't tell you. I have no idea. Jamie, anything else you would like to look at?
I think that's everything I have.
All right. Niko,
I think I'm good.
we do get a lot done. I hope you guys are okay with stopping early, but you know, there's a lot here. That it?
I think I'm good. Yeah.
Okay.
Yeah.
You guys
Thank
are the
you.
customers. You tell me. All right, great. We'll see you guys next time. I'll send you the notes here shortly and have a great night.
You
Thank
too.
you.
Thank
You
you.
too.
Okay, you're welcome. Bye now.